Hello everyone. In this lesson, let's learn the operation detection of mechanical transmission device components. Everyone, what happened in this video? If this is an auto parts factory, such a failure may lead to a loss of hundreds of thousands of dollars per hour. So what exactly is the problem? That's right, the transmission device. Have you ever noticed that the chain of a bicycle makes a clicking sound before it brakes? The gear shift lag will occur when the car's gearbox fails. Behind these phenomena, they are closely related to the running state of mechanical transmission components. Today, we become mechanical doctors and learn how to make a diagnosis of these seemingly cold and hard transmission components. Next, we will learn through the following contents. Through the study of this lesson, I hope everyone can master the basic principles of operation detection of mechanical transmission components and understand the operating status of mechanical transmission devices in practical applications. Be able to correctly select detection methods and tools according to the working requirements of the transmission system, and reasonably configure relevant detection equipment to complete the running status monitoring and fault diagnosis of the transmission device. Cultivate everyone's rigorous working attitude in engineering practice. Enhance your ability to solve practical engineering problems, and stimulate everyone's thinking of innovation and optimization in the field of mechanical transmission technology. We should start with the installation of stepper motor and coupling to learn the content of this course. The first is the installation points of the stepper motor and coupling. 1. The outgoing direction of the stepper motor is subject to the convenience and beauty of the wires, which is convenient for subsequent maintenance and overhaul. 2. The stepping motor should enter the coupling to about half of the length of the coupling. 3. The stepping motor, coupling, and working shaft should ensure coaxiality. Loosen the coupling bolts and turn the motor shaft several times by hand to correct the coaxiality between the stepping motor and the coupling. 4. During the assembly process of the stepper motor, it should be ensured that the encoder at the rear of the motor is not subject to external force, and it is strictly forbidden to knock stepper motor shaft. Next is the learning content of belt and pulley installation. The installation requirements of the belt and pulley are as follows. 1. The driving and driven wheel shafts must be parallel to each other, and there must be no skew or swing. The inclination error should not exceed 2%, otherwise it will affect the transmission efficiency and the life of the belt. 2. When the width of the two pulleys is the same, their end faces should be on the same plane, and the axial dislocation of the two pulleys should not exceed 5% of the rim width to ensure the uniform stress of the belt. 3. When assembling the belt, do not forcibly pry into the pulley. It should be assembled by shortening the center distance between the two pulleys, otherwise the tensile layer of the belt will be damaged, and its performance will be affected. 4. After installation, the belt should not be too tight or too loose. The tension of the belt should be adjusted to the specified requirements. The installation position of the motor should be adjusted to meet the specified requirements. High tension will cause wear of the mating shaft, and low tension will cause deviation in the positioning of the motor. 5. After the punching mechanism is installed with V-belt, the V-belt should be installed in the middle of the pulley and cannot touch the bottom of the pulley, otherwise the wear will aggravate. It cannot exceed the upper part of the pulley, otherwise the transmission power will not be enough, and it can be controlled by adjusting the installation position of the motor. 6. The pulley is fixed on the shaft and should be fixed by tightening screws. Then we will learn the adjustment and connection of sprocket frame. 1. The heights of the two sprocket frames are adjusted to the same reference point, and the center heights are unified to ensure the stability of chain transmission. 2. The two sprocket frames are installed on the vertical plate of the punch press, and should be adjusted to the same vertical surface to avoid unstable chain transmission caused by the skew of the frame. 3. The two sprocket frames are bolted to the vertical plate of the punch press, and should be reliably connected to ensure that they will not loosen during operation. 4. The tightness of the chain should be appropriate. If the chain is too loose, the chain climbing phenomenon will occur during the transmission process, resulting in the upper and lower die plates of the turret components being out of sync. If the chain is too tight, radial force will be added to the upper and lower die plates of the turret component, resulting in out-of-tolerance coaxiality of the upper and lower die plates of the turret component. After studying the adjustment and connection of the sprocket frame, let's learn about the installation of the pneumatic positioning module. 1. Before installing the trachea, the shearing requirement of the trachea is that the incision is smooth, and the cutting powder and dust in the trachea are fully blown away. Otherwise, it will easily lead to air leakage and damage to pneumatic components after being inserted into the joint. 2. After the air pipe is installed, it is generally placed in the line tank, leaving enough space, especially at the corner. The upper and lower die plates of the turret components have wireless slots for pneumatic positioning modules, so the air pipes must be bundled to ensure that the air pipes are neat and beautiful without affecting the operation of the equipment. 3. When the pipe joint is fastened to the pneumatic component, attention should be paid to the length of the joint thread to avoid damage to the pneumatic component caused by too long thread. 4. The raw material tape is generally wound according to the head of the pipe at the production site. The raw material tape is wound clockwise, and a few teeth are reserved. The raw material tape shall not be mixed into the valve. 5. The cylinder joint should face the upper and lower die plate positioning holes of the turret component to facilitate the adjustment of the positioning angle and direction. 6. Control the extension speed of the positioning cylinder by adjusting the opening size of the throttle valve. At the end of this course, let's discuss the detection plan for the component assembly and adjustment process. The following are 4 commonly used detection plans for pulleys. The first assembly inspection content is pulley radial runout. The assembly detection and adjustment method is: the dial indicator is adsorbed on the vertical plate of the bed. The dial indicator head contacts the radial surface of the pulley. Rotate the pulley, and the runout error of the radial surface of the pulley is detected. Generally, the adjustment method is tightening the bearing installation clearance to reduce the radial runout and axial serial error of pulley. Its checking tool is a dial indicator with an accuracy level of 0.01 mm. The second assembly detection content is the axial runout of the pulley. The assembly detection and adjustment method is: the dial indicator is adsorbed on the vertical plate of the bed. The dial indicator head contacts the axial surface of the pulley. Rotate the pulley, and the runout error of the radial surface of the pulley is detected. Generally, the adjustment method is tightening the bearing installation clearance to reduce the radial runout and axial serial error of pulley. Its checking tool is also a dial indicator with an accuracy level of 0.01 mm. The third assembly inspection content is the dislocation detection between two pulleys. The assembly detection and adjustment method is: take the steel ruler close to the end faces of the two pulleys, and the gap between the two pulleys and the steel ruler is detected with a feeler gauge, so as to detect the dislocation between the two pulleys. The measuring tool is a steel ruler plus feeler gauge. The accuracy grade is 300 mm plus or minus 0.011 mm. The fourth assembly detection content is the misalignment detection between the two pulleys. Trial operation of transmission mechanism. The assembly detection and adjustment method is: switch the control switch to the jog state, and carry out the trial action. Test whether the action of the whole mechanism is normal, and find out the reason and adjust the mechanism. The inspection tool generally is visual inspection. In this lesson, we learned the operation detection of mechanical transmission device components. Through courseware demonstration and case analysis, everyone not only mastered the detection process and troubleshooting skills, but also deeply understood the significance of standardized operation to the safe operation of equipment. I hope that you can continue this rigorous and practical style into the follow-up training and lay a solid foundation for growing into outstanding engineering and technical talents. Finally, please think about this course and complete the following exercises, aiming at consolidating the knowledge points you have learned today and further deepening your understanding. This lesson ends here. See you next time.